So here I'm going to show you a super easy way to balance chemical equations. Usually if you take like general chem in high school or college, they just show you like a trial and error method to balance chemical equations, and there's more of an analytical solution that you can do using something called a linear algebra and forming a system of equations. Sounds complicated, but it's actually really easy to do. So the first thing I'm going to show you is just a trivial case that anybody can do in their head. But if, let's say, you had a homework, an exam problem, and they said that we want to balance this equation, hydrogen plus oxygen equals water. And here are the steps that you do to balance this using sort of the analytical approach. Is you write out the equation, which I've done here, and then you just add some variables. A, B, C, you call them anything you want, x1, x2, x3. It's up to you. Then step 2 is you form the atomic vector and list all the atoms. So you have this vector, which is just this column vector, and all of this is a list. And you put in all the different types of atoms that are in your reaction. So you say, okay, there's hydrogen. Okay, so we add some hydrogen. There's oxygen. Okay, we add oxygen. And the last one has hydrogen. Oh, we already have hydrogen. And we have oxygen. Well, we already have an oxygen. So that's it. Then you rewrite the chemical equation in a vector-like chemical equation. So we have that coefficient A from above. And then we have our list of atoms. And we have B in a list of atoms equals C in a list of atoms, okay? And so what do we do with this? Next is you plug in what you know. So here's the general chemical equation. Here's what we wrote. And now we're going to start putting the specifics. So we have this A variable. That's some coefficient that we're going to determine. And how many hydrogens was in the first species? Well, that was just a hydrogen. It had 2, so we write 2. And how many oxygens? Well, there's none. And B, this is the B species that we're trying to determine. How many hydrogens does it have? Well, it doesn't have any. How many oxygens? It has 2. And then we equals C, and how many hydrogens? Well, we have 2 hydrogens in water and 1 oxygen. Then we move everything to the left hand. And so all I'm doing is moving this C term over to the other side. So over here. And we're making it all equal to 0, 0. And so we have, and then all I do in here is I pull that minus sign, or that's right here, inside of the vector notation. And so this 2 and 1 become -2 and -1. And then we form a matrix. And so we have, all we do is we take all these little column vectors and we just squish them all together. So 2, 0, 0, 2, -2, -1. And then all the coefficients become a column vector, A, B, and C, and that's equal to 0 and 0. And then I say, use a calculator to put the matrix in reduced row form. So this is the matrix. And on your calculator, all these scientific calculators have a way to do this. Like in HP calculators, you make a matrix, and then you go into the menu, matrices, linear systems, and you issue this command, RREF. And it will change this matrix into the reduced row form. And in TI, you have to do alpha zoom. That'll create a matrix. You store that matrix in A, and then you go back into that matrix menu that you have in your TI, and you issue this command, RREF, basically the same command that was on the HP, and you tell it to use a matrix that you created. And then you just read out the answer from that, okay? And so we have 2 equations. So we have 2 equations that are in reduced row form, and then we have a column vector. So what you do is you just take your row times the column. So we have 1 times A, 0 times B, minus 1 times C equals 0, and then you solve for A. And you get A equals C. The problem with this equation is we have two equations and three unknowns, so we had to set c equal to something, so we just call it x. So we have a equals x. And then for the next equation, we have 0, so we take a row times a column, 0 times a, 1 times b, minus 1/2 times c, and we solve for b. So b equals 1/2 c, but we already said c is equal to x because we have more unknowns in equations. And so our final answer that we determined from this matrix is a is equal to x, b is equal to 1/2 x, and c is equal to x. And now we say, okay, what can I make x so that there is no fraction? What is the smallest number that I can make x so there's no fractions? 2, because 1/2 times 2 will be equal to 1. So I say x equals 2. So that means a is equal to 2, b is equal to 1, and c is equal to 2. And there's your final equation. So we say this is a is equal to 2, b is equal to 1, c is equal to 2, and our equation is a balance. And that's pretty trivial, and that was a lot of work to do just for a trivial case. But, well, now we'll do something a lot harder. And so, let's say on a homework or exam, they give you this equation. Copper plus nitric acid equals copper nitrate plus nitrogen monoxide plus water, and they say, what are all the coefficients? That would take you a long time to figure this out. On an exam situation, you'd probably skip it and save it for last, because it's just going to be a lot of trial and error and hunting and pecking. But it's the same procedure as that trivial case. First, you write down the vector of all the atoms that are, all the different types of atoms that are in your equation. So you have a copper, okay, I got a copper, I have hydrogen, I have nitrogen, I have oxygen. Okay, and there's copper. Well, I've already wrote that down. I already wrote down nitrogen. I already wrote down oxygen. Nitrogen, oxygen are, so all of the atoms that I have are already represented here. And it doesn't really matter the order that you put this in. If you did it in some different order, it doesn't make any difference. Just as long as all the atoms that you have are represented in here. And then you form the coefficients, you know, A, B, C, D. These are what you want to determine. And then you write down what's in it. So in the first species, there's just one copper, and there's no hydrogen, nitrogen, or oxygen. In the second species, which is represented by B, there is a hydrogen, so we put that there. There is a nitrogen, 1, and there's 3 oxygens. And that's equal. We change the arrow to an equal sign, and we have copper nitrate that has 1 oxygen, or 1 copper, no hydrogens, 2 nitrogens, and 6 oxygens, plus the nitrogen monoxide, which just has a nitrogen and an oxygen, and the water, which has 2 hydrogens and water. We form our matrix. Well, I skipped a step here. I moved everything over and then moved the minus sign in. So now we have, this is our new matrix. Again, we have only 4 equations and 5 unknowns, so we're going to have to set that last one, e to equal to x. But this matrix now, you can just shove into your calculator, and it calculates what the reduced row form is. And then you just read off the answer, assuming that e is equal to x. Again, you do row times column. So we have, if you do the first row, 1a, 0b, 0c, 0d, minus 3/4 e. But e we said was x, okay, just because we had to have some variable for it. It's unknown. And we just solve. A is equal to 3/4 x. So that's all I've done right here. A is equal to 3/4 x, b is equal to 2x, c is equal to 3/4 x, d is equal to 1/2 x, and e is equal to x. And now you look at all these guys here, okay, and say, what can I make x be? What is the smallest number that I can make x be so that there's no fractions? And I say, well, I can make x equal to 2. No, there would still be a fraction in this one. So I make x equal 4. If you make x equal 4, then a becomes 3, b 8, c 3, d 2, and e is 4. So that's your answer. That's your coefficients, 3Cu plus 8 HNO3, 3C copper nitrates, 2 nitrogen monoxides, and 4 waters, you know. And so there's no trial and error in it. It was just, you make the matrix, you hit the reduced row form on your calculator, and basically you just determine what x should be. Okay, what's the next one here? So here is just another example where I say you're given the ammonia plus copper oxide equals copper, nitrogen, and hydrogen, and they want you to balance it. And here I'm just skipping a lot of steps now. I write my vector, and then I just start filling it out. And make the matrix, make sure all the stuff on this side is negative, which it is, and all the stuff on the right hand side becomes negative, and all the stuff on the left hand side is positive. You just hit the reduced row echelon form on your calculator, and then you just look at this last column and say, well, what do I need to times it by to make it no fractions, the lowest number? And it's obviously 3. And so you get A equal to 2, B equal to 3, C equal to 3, D equal to 1, E equal to 1. So that's your answer right there. Now here's a complicated one that I did, and I just time myself and say, okay, given this equation, how long would it take you by trial and error? It'd probably take you a while. But just immediately going in, the first step was I make my vector, and then I'm just entering this into my calculator. I enter the matrix directly. I don't even write it down. And so I say, okay, S is equal to 1, 0. The first column is going to be 1, 0, 0, 0. Second column is going to be 0, 1, 1, 3. And I just enter it directly in my calculator, directly push the reduced row form, then look at the last column and realize I need to times everything by 2 to get rid of all the fractions. And it takes me approximately 1 minute to enter it, times it by 2, and then write this out and say, hey, this is the answer, 1 sulfur, 6 sulfuric nitric acids. And so this is a much quicker than if I had to trial and error and figure out what the heck the balanced equations would be on this one. So this would be a great way to check yourself on an exam or a test, even if your professor said, hey, I want you to do trial and error and show all your work and stuff. You could easily check it in 1 minute to see if you got it correct. But ultimately, different calculators have different ways of doing it, and you're just going to have to look at your manual and say, how do I enter a matrix, or how do I create a matrix, and then how do I perform this operation, reduced row form on it. And then from there, it's fairly trivial. Like I said, you can just look at the equation and immediately write out the matrix, make sure the stuff on the right-hand side is negative, stuff on the left-hand side is positive, and just hit the reduced row, and then whatever the last column is, just times that by whatever you'll get rid of the fraction, and then you write out your answer, and that's it.